What is this called, John?
This is called a quantum tunneling instrument now. You'll see the laser coming through. Okay. So this is a quantum tunneling device. And what the idea is that 99% of the photons or electrons are going to be stopped at the wall. Okay. But in quantum theory, some are going to pass through the wall. There's information contained in the walls of this building, and that through quantum tunneling, you might be able to divide some data sets out of it. Okay, this is what the raw image looks like. Okay. Actually do is try to create a matrix of lasers inside Casa Rinconada, and specifically is it the 7th niche, DB?
The 7th niche.
Yeah, okay, and we're going to shine a laser in there, and then we're going to get a rebound from the laser into Jim's telescope. So that's basically the setup, and this is strictly an experiment.
And on his telescope, is there a CD camera?
Yeah, CCD
that will
camera
record this?
That will record this.
CCD camera.
We'll know it's closed when we see John.
Where'd you get the cool camera? John. Oh, wow.
So it's taking, for anybody who wants to see how the system works, it's doing the image in 3 colors. So there is in red, and what you're probably getting is the heat off the rocks. So that's the niche, and that's the laser in there. Let's see.
What's the software you're using?
This is astronomy software, actually. Okay, we're going to combine those 3 images into one image.
Oh, ooh, pretty. Majorly cool. Look at that. Wow. Okay. Hey, I'm convinced.
And it's pointing. It's pointing towards something. Maybe that's where Elvis is buried.
Oh yeah. Okay. All right. When are we going to shine our sight?
Yeah. Now, if it's dark enough, if we can actually see the trails of the lasers, that's the important part. Can you see these lasers actually, when they hit the rocks and they return, that they actually are altered? That these walls are actually being constructed now in a parallel universe. As we stand here, there are Chacoans in a parallel universe, not identical but parallel, that are building.
Hang on.
So the idea was,
that's how you do create a hologram.
Yeah, that's right. That this laser that's being shot toward the 7th niche will be intersected by 2 lasers shot from there, and that if they intersect, if there was dust or if it's dark enough, you'll see those lasers intersect, and that's what we want to photograph too.
What?
Because that might create the hologram. That there may be actually some construction in the energy of this building that could create a hologram.
Hi, John.
Hello.
I would like you to just tell us a little bit about what's going on here at Casa Rinconada tonight.
Well, we are doing a kind of a vortex experiment, and the kind of the background on it is a parallel universe concept. So we have a crystal and we have it on a string. Nobody's allowed in Casa Rinconada anymore. So we have a crystal on a string that's positioned in the middle of the Kiva. And what we're going to do is, through laser light, we're going to see what effect the laser light has on that crystal. Because what these Kivas are areas of information. And we think they might be portals to a parallel universe. Oh, wow.
Oh, look at that. Wow.
Yeah, Jesus. I think it's building up energy to critical mass.
Okay. Wow, the base, now there's energy shooting up out of the top, which is actually the bottom of the crystal.
Okay. Cool.
What's that?
There it is.
Okay, so this is what came out of the data last time. This configuration.
Oh, I'm sorry.
We have different interpretations.
It's really limited the number of photons that have come through, and what should happen is you shouldn't get any of these patterns. what you should get is a straight line, because those photons should be going through that slit and just hitting like a vertical pattern. There shouldn't be any of this spreading out of these interference patterns. So that's Deutsch's contention that there's a parallel universe. That's how he extrapolates. And he thinks that if you build a quantum computer, and he's got the mathematics to show this computer would tap into the computers in all the parallel universes, and it would be able to, the computation would be just enormous. And there's some mathematics that proves that.
But the old description of this, the old interpretation was the classic Copenhagen school, which was that this dual slit thing, dual personality of light. Under some conditions, it responds and appears as a particle. Under others, it responds as a wave. So we have this dual identity of light that's never been fully explained. David Deutsch thinks he knows the explanation, which is a connection to parallel universes, which is a viable set of theories in physics right now.
So it kind of makes the subatomic quantum world the same as the world we see.
Never has been.
And with all these universes, everything that's possible has already happened. So you can have these quantum effects of a table disappearing and ending up in Denver, your table, it could come back. All these possibilities are there, but they're not in our universe. So that's how he gets around the whole Einstein thing of classical physics, that these parallel universes, they fulfill the idea of quantum mechanics. So, and just to dump classical physics, it's all going to be quantum.
So you could build a quantum computer that would tap into all the existing computers and all the other parallel universes.
Right.
Then somebody in one of these other parallel universes could do the same thing, right?
Absolutely.
It hasn't happened.
It hasn't. Well,
we don't know.
We don't know.
This could be
See, now it's taking a picture of itself with the shutter closed. So it's going to take all this stuff out of it, hopefully.
And then you have to ask yourself, where is the quantum computer doing the calculations? I mean, your computer can only do, it can store a number of a particular size because it's got the memory space. Where is the quantum computer doing the calculations if it's using more physical resources than exist in our universe? And David Deutsch, who's a physicist at the University of Oxford, says that what the quantum computer does is exploits parallel realities. It exploits copies of itself in parallel universes. So when you set a quantum computer a problem, it splits into multiple copies of itself in parallel realities. They all work on threads of the calculation, and they come back together again with the answer. So he says the quantum computer is something entirely new under the sun. It's the first thing we've ever invented that exploits parallel universes.
The universe that we see around us is real, but it's only one small facet of reality. The whole of reality consists of many such universes, and they're all equally real, and we call the whole set the multiverse. I studied physics at Cambridge, and then, and after that, I was always on the borderline between different subjects. I studied quantum field theory in an astrophysics department, and then I studied. I came to the multi-universe theory in the Relativity Center in the University of Texas at Austin.
But why would we need multiple universes?
Suppose you take one of the classic experiments of quantum mechanics, for instance, the prediction of the interference of light. Now, I can show you interference on a simple laser, which we can... I shine the laser through the hole, and we can see a little spot on the screen over there. And what would you expect to see? You'd expect to see, just if there's one hole, you'd expect to see one spot, but that's already not true. You see quite a complicated pattern. It's called an interference pattern. I'll tell you why. What would happen if we made a second hole? Well, here's another place on the screen where there are two holes. We get a completely different pattern. And through three holes, there's a different pattern again. That's the pattern we get from four holes. The surprise is that even with this one photon at a time coming through the holes, the pattern is exactly the same as it was when we were shining the bright laser light through. Well, the question is, how do we explain the fact that we see the same pattern, that we detect the same pattern on the screen, when there is only one photon at a time going through? And what we must conclude from this is that something is coming through those other holes and shoving our photon aside. And that process is interference.
What is this something?
Well, we can do further experiments to find out what that something is. The conclusion that we draw is that this thing behaves like light in every way we can detect experimentally except one. And that is, we can't detect it.
So it's not there.
It is there because it pushes aside the light that we can see. And it behaves like light. And the only reasonable conclusion is that it is light of an invisible kind. Now, that doesn't take you all the way to concluding that there are many universes. But the thing is, quantum theory predicts all this, and in the equations of quantum theory, these invisible bits of light appear in the equations. In this experiment, we can see however many holes we make, there is a different pattern. Even when one photon is going through, there's a different pattern for 6 holes, for 7 holes, for 100 holes, for 1,000 holes. And that means that there must be something traveling through every one of those 1,000 holes and making a difference to the photon that we see.
Making thousands of parallel universes.
And that means there must be at least thousands of parallel universes. In fact, the theory tells us there are a lot more than that.
I mean, am I a part of many universes?
You have to start thinking of yourself as not as an entity existing in one universe, but an entity existing in the multiverse as a whole. And so there are other copies of you and of me in other universes. Some of these copies are completely identical to us. There are other universes which are very like this one, but differ only in the position of one atom somewhere. Now, those universes are interfering with ours, and they are producing interference effects, which we could detect in the laboratory if we wanted to.
All of our everyday experience is conditioned by multi-universe interactions. For example, matter couldn't be solid if each atom only took one path. What keeps it solid is the interactions between different instances of the same atom in different universes. That is what makes for rigidity. It's also for what makes permanent magnets. It's also the reason that we can have amplification of signals. It's the reason that we can see stars. If we're talking about the number of different histories that's happening in, let's say, a cubic meter of air, then we're talking in terms of 10 to the power of 10 to the 23 different histories are all happening at the same time.
And so that's the number of different histories of this 1 meter of air.
One has to understand it in this way. Well, first of all, yes, they have existed since the Big Bang.